All right, so we're going to talk about a couple of concepts related to angles that are going to be important to us. The first one is what are called coterminal angles. And any angle that you make has an infinite number of coterminal angles. In other words, for example, we've got 30 degrees here. 30 degrees is referring to the rotation that was used to make this angle. So 30 degrees tells me that I started here on my initial side and I rotated counterclockwise or up 30 degrees. And this is where my terminal side ended up. There are other ways that I can make this same angle using a different rotation. So for example, one way that I could make this angle would be, instead of just going up 30, going up 390 degrees. So in other words, I would go all the way around the circle 360 plus 30 degrees more. And 390 would have started in the same place and ended in the same place as 30 did. So 30 and 390 are coterminal. They stop in the same place. They just take a different rotation to get there. Likewise, I could have also, instead of going counterclockwise, I could have gone clockwise. So instead of going up 30 or around 360 and then up 30, I could have gone backwards or down or clockwise, negative 330. That same rotation, or that rotation would give me the same initial and terminal sides. I would have started in the same place and ended in the same place, but I just went a different route to get there. But this would still be 30 in here. So 30 and negative 330 are also coterminal. And you can repeat this idea of rotation in one direction or the other as many times as you want to. I could, instead of stopping at 390, I could have gone around again, and that would have been 750. Or I could have gone around again, and that would have been, let's see, I think 1110, something like that, add 360 basically. Or instead of going in a negative direction just one time and going negative 330, I could have gone in a negative direction, 360, and then around again 330. So negative 690. Right? So hopefully you're kind of seeing a pattern here. And the pattern is that you can find coterminal angles to a given angle by just adding or subtracting rotations. So if you look here, we've got 30 plus 360 gave us our coterminal angle of 390. And 30 minus 360 gave us our coterminal angle of negative 330. So basically, if you add or subtract 360, you can find coterminal angles. Now these examples, the angles were in degrees. So if you have an angle in radians and you're trying to find coterminal angles to it, then 360, remember, is the same as 2 pi radians. So you could also add or subtract 2 pi radians if you were working with radians. So here are a few examples. This says, give two angles, one in a clockwise direction, that means subtract 360, and the other in a counterclockwise direction, that means add 360, that are coterminal to these. So 500, if I subtract 360, is 140, and 500, if I add 360, is 860. So these angles are coterminal to 500. That means they have the same starting and ending sides. They just rotate a different way to get there. Negative 360, if I subtract 360, I get negative 420. And if I add 360, I get 300. So those are coterminal to negative 60. Okay, now when you go to do your coterminal angles for your radians, okay, if I subtract 2 pi from pi over 4, and I want to leave my answer in terms of pi, then what I'm going to do is I'm actually going to subtract 1/4 minus 2. You can use your calculator to do that. You can just type in 1 divided by 4 minus 2. And you should get negative 7/4. So this would be negative 7 pi over 4. That would be your clockwise rotation coterminal angle. And same thing, if you added 2 pi, you could get one in a counterclockwise direction. So 1/4 plus 2, That's 9/4, so 9 pi over 4. Right, negative 2 pi over 3, if I subtract 2 pi, so negative 2/3 minus 2 should be negative 8/3, so negative 8 pi over 3. And then if I add 2 pi, negative 2/3 plus 2 pi should be 4/3, so 4 pi over 3. So the idea is just to add or subtract 360. When you're adding, you're finding the one that has counterclockwise, that would be in a counterclockwise direction, and when you subtract 360, you're finding the one that would be in the clockwise direction. All right, the next idea, and this one's really important as we start getting into the actual trigonometry we're going to do next week. This idea is called a reference angle. And a reference angle is the smallest positive acute angle determined by the x-axis and the terminal side of theta. That's pretty wordy, so I'm going to break it down for you. What it means is that you're going to try to find the angle that's between your terminal side and the x-axis. All right, so I'm going to kind of show you, and then we'll come up with some formulas that you can use depending on what quadrant your angle's in. So for example, let's look at 150 degrees. So if you think about where 150 degrees is, it is in the second quadrant. It's 60 degrees past 90, right? So this is 150. The reference angle refers to the angle here. If you were to go straight down from your terminal side, remember this is the terminal side, to the x-axis, the closest path you could take, what angle would this be? So hopefully you can see that you're 30 degrees away from 180. So the reference angle for 150 is 30. Let's try another one. So 315. 315 is in the fourth quadrant, right? If you start here and you go around 90, 180, 270, and then 45 degrees past 270. That's 315. So the reference angle is the angle if you go from your terminal side straight to the x-axis. What would this angle in here be? And so hopefully you can see that you're 45 degrees away from 360. So 45 would be the reference angle. Okay. Now with radians, you may have a little bit more trouble. Again, if you want to do it like I did it when I first started learning radians, you can convert these into degrees if you want to. Remember, cancel the pi and multiply by 180. In this case, you would get 240. All right. So if you think about where 240 is, oh, let's see, let me do this. So if you think about where 240 is, 240 is going to be in the third quadrant. 90, 180, 240. All right. You're 60 degrees past 180. So your reference angle is going to be this angle in here. How far past you went 180? How far past 180 you went? So 60 degrees would be the reference angle. But I want to put it back in radians since the problem was in radians. So remember, you give yourself a pi and divide by 180. So the reference angle would be pi over 3. So let's try pi over 6. So pi over 6 is the same as, if you cancel the pi and multiply by 180, is the same as 30. All right, so 30 degrees is in the first quadrant. All right, so this is going to be kind of weird. Let's look at it. So from the terminal side back to the x-axis is 30 degrees. So 30 degrees is its own reference angle. All right, so we're going to talk about that in just a second. So in this case, 30 degrees is the same as pi over 6. So pi over 6 is its own reference angle. Kind of weird, right? So let's look at some rules that we can generate for this. So there are rules for finding the reference angle in each quadrant. And we kind of just saw those. If you go back and look at the examples we just did, we had an angle in each quadrant. For the last one that we did, that was the angle in the first quadrant, and notice that it was its own reference angle. So if this is our angle here, theta, the reference angle, which I think they use the letter alpha up at the top here, is equal to theta. It's its own reference angle, right? And this Greek letter theta is often used to represent an angle. So in quadrant 1, these angles are their own reference angles. In quadrant 2, since you're measuring how far your angle is from 180, the reference angle is going to be 180 minus theta, if you're working with degrees, or pi minus theta if you're working with radians. Okay. In the third quadrant, right, this is your angle, this is theta, so you're measuring how far past 180 you've gone, so it's theta minus 180, or if you're doing radians, theta minus pi. And then in quadrant 4, this is your angle that you're talking about. You're measuring how far you are from 360. So you're going to do, 360 minus theta if you're dealing with degrees, or 2 pi minus theta if you're dealing with radians. Right. So tomorrow in class I'll give you a foldable that kind of summarizes how to find the reference angle. I've gone over my 10 minutes, so I'm going to try to do the next part kind of quick. So if you need to pause it, you can. So the last thing that you're doing in here is just labeling some of the special angles on the unit circle, which we'll talk about the unit circle more. So I'm going to start with the 45s. So it says label each angle using degree and radian measure and positive rotation. So this is 0 degrees or 0 radians. And then this circle we're going to show every 45 degrees. If you look, it's divided up into 8 slices. Each slice is halfway between your axis, your X and Y axis. So this one would be 45. And remember, 45, if you make it into radians, is going to be pi over 4 radians. 90 is pi over 2. 135 is 3 pi over 4. 180 is pi. 225 is 5 pi over 4. 270 is 3 pi over 2. And 315 is 7 pi over 4. And then we're back to 360, or 2 pi. Now I want to show you a little trick with the radians here, right? So as we go around with the degrees, we're adding 45 each time. So 0, 45, 90, 135, 180. But look at what happens with the radians. We go 0, 1/4, 2/4, right, which reduce to 1/2, 3/4, 4/4, which reduces to 1, 5/4, 6/4, which reduces to 3/2, 7/4, 8/4. So just like we're adding a 45 as we go around, we're adding a 1/4 pi, but some of them get reduced. All right, so you'll see a similar pattern when we do the 30s and 60s. So I'm going to actually pause the video real quick and fill those in, and then if you have trouble understanding where they came from, you can ask me in class, but I don't want to make this video any longer than it already is, so I'm just going to pause it real quick. Okay, so there's a lot more to this one. I know it's kind of hard to read, and I'm eventually going to give you one of these that's got them all filled out. But notice the patterns here, too. We're adding 30 each time. And notice we start out over here with 1/6 pi. Then we have 2/6, which reduced to a third. 3/6, which reduced to a half. 4/6, which reduced to 2/3. 5/6, 6/6, which reduced to 1. 7/6. 8/6, which reduced to 4/3, 9/6, which reduced to 3/2, 10/6, which reduced to 5/3, 11/6, oh, and then I forgot the 12/6, 360 degrees, or 2 pi. Notice that all the angles in the first quadrant over here just have pi on top. All of these over here, the top number is 1 less than the bottom number. Here, the top numbers are one more than the bottom number. Here, the top numbers are one less than twice the bottom. Start trying to pick up on these kinds of patterns, and we'll talk about this circle more later.